This podcast is sponsored by Lightstep. Lightstep delivers confidence at scale for those who develop, operate, and rely upon today's powerful software applications. Answer questions and diagnose 100% of anomalies, spanning mobile, monoliths, and microservices across every service in real time. Visit lightstep.com.
Hello and welcome to the InfoQ podcast. The podcast and QCon, a family of software conferences that I chair, are focused on an audience of senior software developers and architects. This podcast features interviews with guests who you'll often find speaking at the conference. Recent guests include Vaughn Vernon on domain-driven design, Justin Cormatt from Docker on decomposing the modern operating system, and we have upcoming ones with Martin Fowler talking about his new refactoring book, Brian Getz talking about the JVM and Java, Tanya Reiling talking about SRE stuff, and Camelia Fournier talking about the move from developer to management and things around distributed systems. On today's podcast, we're talking to Mitchell Hashimoto. Mitchell is the founder of Hashicorp. He's the creator of Vagrant, Packer, Surf, Terraform, Vault, Nomad, and I'm sure I forgot something else here. In particular, on today's podcast, though, we're going to be talking about Consul. Consul is a service mesh solution providing a full-featured control plane with service discovery, configuration, and segmentation functionality. Now, it's interesting. Until recently, I've always thought of Consul as a distributed key value store. So today I want to talk to Mitchell about that and kind of clear up my own confusion on it, and also talk about products like Consul Connect that's part of it, usage patterns with Consul now, features, benefits, and maybe a bit about the developer experience of using Consul. So we'll see where it all goes. As always, thank you for inviting us along with your commute, your jogs, and your runs, and we look forward to a great show. So Mitchell, thank you for joining us on the InfoQ podcast.
Thanks. I'm excited.
So I've rattled off like a whole bunch of things up here about products that you've created. What did I miss in this?
I think you got all the ones that are reasonably successful. You missed all the failures, but then no one knows about the failures, so that's okay. It's just important to know that there are failures.
Yeah, that's our super great point. So what was the first one? Was it Vagrant?
It was. And again, I always clear up that it was the first non-failure, but it was the first open source project that really took off. Yeah.
Okay, so then tell me about the first one that failed. What was that idea?
I honestly don't even remember. I love open source. All the work I did usually became open source. And there was all sorts of little libraries and other tools that I built over the years that I released that just never really, gathered much adoption. And so, yeah, I don't remember them much anymore. But Vagrant was the first one that succeeded in some sense. And you can find stories about that elsewhere, but that also took a while. So it wasn't like overnight. It took well over a year before it started getting some good traction.
What's the short version of the Vagrant story?
The short version is that I was working for a consultancy shop as a junior developer, and I was getting really frustrated about the time it took me to set up and change my environment between clients. I felt like I couldn't help my coworkers without a significant investment in time that usually wasn't worth it. So no one helped them. They were underwater. I felt that way about my own work if I needed help. And so I really wanted, the motivation in my mind was, I was using Mac at the time, but I was thinking in a Windows mindset. Like my motivation was like, how do I double click a client on the desktop and be ready to work? And that was the goal.
I specifically remember the day that someone who was working on our kind of delivery pipeline for the startup that I was working on, he goes, hey, you got to see this tool. I specifically remember the day that he brought me Vagrant, and I was so excited when I discovered it too.
Nice.
Awesome tool.
Thank you.
Okay, so let's talk a little bit. So as I mentioned in the introduction, when I've always thought of Consul over the past, I've always thought of it as kind of a key store. But when I was kind of prepping and doing some work for this and reading some work and everything, I see Consul called a service mesh. Have I just been off base? Has there been a shift? What's the story there?
Yeah, so Consul is a key store on its own. It's very common that people will see it as a key value store. And it's kind of unfortunate because in my mind, that's actually it's important for the problem it's trying to solve, but it's the least important problem in my mind. And so I would put it like as the lowest priority a key store. And then when you kind of push that out of the way, it becomes a little clearer of what it's trying to solve. And really what it's trying to solve first and foremost is being a centralized service registry and providing discovery. So a place where you have all your services, it provides DNS to discover them. There's metadata about those services you could store and things like that. That's sort of problem number one, is how do I find my services? Problem number two is often, how do I configure those services? And that's where the KV came in. It's this world where you have a ton of services, you have a lot of instances of those services. You just want a lightweight key value store, but for that focused purpose of service configuration. And if you think of, the most complicated software and how much config they have, it's usually at most, and this is extreme on its own, at most it's like kilobytes, but usually it's like less than a kilobyte, it's just some, a few hundred lines of text. And so that's really what the KB store was made to do. And then the third problem, which we just got into in June, is the service segmentation problem, which is, you could find your services, you could configure them, but now the challenge is how do I actually connect to them and control who can connect to those services? And that's really leading into the service mesh, how we call Consul service mesh today, because what we found is service mesh is definitely a sort of category of problem that companies and the community alike want to solve, but it goes hand in hand with the discovery and configuration problem. So when we were talking to our own users and doing discovery, we realized that Consul was very close to solving their service mesh problem, and that's why we came out with Connect.
So what you're talking about is in June of this year, Consul 1.2 came out, which offers this new feature that talks about Connect. So what is Hashicorp Connect really excelling at? What is it doing that's expanding this space of service meshes?
I like to describe it as the most basic thing. It's solving service to service authentication and authorization using TLS. So the problem is really, the way I like to describe it to an individual, not a company, but just an individual, was just imagine, a small personal side project or something that you're deploying, and the sort of database to web server or web application component. Like usually every database sort of supports TLS or some encrypted connection as a mechanism, but usually you end up using just like unencrypted connections for your personal side project. Why is that? And the answer is usually because it's just easier. It's easier to use an unencrypted connection, even though anyone might know that it's the right thing to have an encrypted identified connection. And what we're trying to do with Connect is make it that the easy case, make it basically automatic that you always get that encrypted connection. And that's what it's doing.
Very nice. Who's using it today for this purpose?
It's also important to realize that we released Connect in June with version 1.2, but Consul itself has been around for over 4 years, almost 5 actually. So it's quite mature as a piece of software. So we have some pretty large users. Some of the public users that allow us to share publicly are people like Twitch, people like Stripe have talked publicly about their usage. When we take a look at sort of the Alexa top 50 of websites, well over a third of those websites are heavy Consul users. And so that's one way to look at it. And we've seen quite large scale of Consul. And again, it kind of goes back to that first question you've asked of like, why would I use it? And if you look at it not as a key value store, it's the service registry problem. That's really what these people are using it for at first.
What about specifically Consul 1.2? Are any of those folks using 1.2 now and using it as a service mesh?
It's not rolled out in the production maybe in one place, not in most places. There are a few active, not more than a few. There's a number of I say few because the number of companies or customers we have is relatively low just because we've serviced the global 2000. So our customer counts in the hundreds, not in like the thousands. But of those customers, we do work very closely with a few that are POCing the Connect feature set. It's a little bit slower, obviously, because they are a global, 2000 company. The rollout of that is not something that happens overnight. The performance requirements, feature requirements they have are pretty important. And so with any initial sort of new feature in a product, it takes a while to get there. And our focus with 1.2 really was initially on the community and the open source, which we are seeing usage in.
Let's talk a bit about that. You mentioned Consul's been out for 4 years or so. There's both an open source version that you can find on GitHub, and then there's also enterprise. What's the distinction between the enterprise version? Are you pushing upstream? What's that look like?
What we try to do with our enterprise products is we try to solve organizational challenges. So we try to push all the technical challenges into open source. So we're solving the problem for you in open source. And what you're getting in enterprise is just the challenges you have just because your organization is large, not necessarily because your deployment is large or something like that. That's obviously could get murky because to solve organizational things, we use technology. Like there's various ways you could sort of squirm around that, but that's the rough outline of the problems. And so with the Consul Enterprise, the things that we introduce are mechanisms for safer leader election in multiple data centers or multiple availability zones, I should say. Things for read-only server replicas, supporting more of those, better automated upgrades, things like that. It's stuff that just helps with the scale that you sort of get to at the enterprise level.
When we're talking about Consul as a service mesh, what's the north-south kind of ingress story versus the east-west? What's the kind of the story around those two?
Yeah, great question. So for Consul, we really focused on east-west traffic. That's what we really try to solve. We don't try to get in the way of north-south. You use whatever hardware load balancer, software load balancer, API gateway, anything you sort of need on the north-south layer, you get to choose. Consul doesn't get in the way of that. A lot of north-south vendors do integrate with Consul so that companies like Nginx and HA Proxy have integrations both in their open source and enterprise versions themselves for automatically reading, dynamic backends from Consul, for example. That is something that does exist, but it's not somewhere we try to replace anything. And then east-west is where we really change things. Consul's really trying to push the idea that you don't need, things like HA Proxy or load balancers in between your east-west traffic. Just talk to the service directly. And the way, we do that is we do some DNS round robin. There's other, weighted DNS you could do. But the idea is that a lot of people use load balancers, not for load balancing, but they actually just use them as a way to get a single IP to route to multiple services. And so because Consul is so dynamic and updates DNS pretty much instantly as services become healthy and unhealthy, come in and out, you just use DNS and you connect to whatever you need to talk to.
What does the kind of bootstrapping story look like? So if you're using Consul, do you install an agent? Do you install server? What am I talking to? Am I talking to a VIP that's basically routing me? What's kind of that user experience look like?
Yeah, so the base, sort of getting started experience for any Consul cluster is you have both a server cluster, which is usually it's a quorum-based distributed system. You have 3, 5, or 7 generally for the quorum. You run those on dedicated machines usually. And when I say dedicated, it could be in the cloud, but just no other software usually running. And then you do install an agent on every machine. The agent helps solve the problem of sort of the initial service discovery. It's like, how do I find Consul to perform service discovery? Well, the answer is it's always localhost port 8500. That's just the answer because you have the agent there. The agents themselves solve that problem using a gossip protocol and all sorts of other neat tricks, but it's sort of left to Consul and not the end user. So that complexity is sort of gone. The agent also does important things like caching and other performance related behavior so that your service discovery is fast, your mutual TLS connections are very quick, things like that. But yeah, you stand up the server cluster, you start spinning up agents, and you slowly sort of onboard services into there. And Consul itself exposes the DNS server. So you either configure your local machine just to point to that DNS server, or you configure some other software like DNS mask. But it's generally really simple because it's all local to the machine.
Some of the questions that I'm curious about are data plane, control plane, layer 4, layer 7. How does Consul deal with the data plane versus control plane? What are some of the features it's doing? What is your take on the two?
It's very important for anybody coming into a service mesh to understand the difference between the data plane and the control plane. So Consul is very firmly a control plane solution. It could look a little confusing from the documentation, that we try to be really clear about it. We do include our own proxy written in Go. But the only reason we include that is for getting started experience. We wanted to make sure that people who are adopting Connect don't need to also learn a second piece of software like HA Proxy or Envoy or something just to kick the tires, basically. And so we have this built-in proxy. We're very upfront that the performance is not great, that it's written in Go, it's memory managed language, things like that. But Consul itself is trying to solve a control plane problem.
All right, so that explains a bit because I was a little curious about the sidecar that was implemented for Consul versus what I also saw that looked like there was some integration work that's being done with Envoy as well. Is that right?
Yeah, so very soon, at the time we're recording this, it'll be about a week or two from now, we are announcing Envoy support for Consul, and we will be sort of making that official in the sense that Consul will expose the Envoy XDS protocol. It won't be for public user consumption. It'll be just for Envoy. I know other software is trying to read XDS. We're not comfortable exposing it that way yet, but we will be supporting Envoy as a first-class thing, and that will be our recommended data plane solution, sidecar solution for production usage. As an example of sort of that integration, we're making it really slick to spin up the sidecar. If you basically have Envoy on your path, you could just run Consul connect Envoy and then a flag that is sidecar 4, and then whatever the service name of that sidecar, and we'll generate the Envoy YAML configuration, bootstrap it, start it up, and then fork exec into Envoy. So it's a pretty easy, slick process.
Well, let's talk network layers, layer 7 versus layer 4. What's the kind of take that Consul takes with these two?
Sure. So a lot of other service mesh software out there launch sort of day one with layer 7. Layer 7 is the awesome demo they show. They show different paths to an HTTP server going to different versions, for example, of a microservice. And I think that's definitely sort of where the future is headed. We launched Consul Connect initially with layer 4 support only. And even currently at the time of recording, it's layer 4 only. We'll be supporting layer 7 very shortly, but it's important to understand why we did that. And to do that, you have to also understand sort of our philosophy behind all the software we write, but definitely Consul, which is that, Hashicorp software tries to work with containers, work with virtual machines, work with on-prem, work with VMware, AWS, Google, all these different heterogeneous environments. And the problem we solve for our customers is that they have stuff everywhere, and we're trying to give them a single solution that works across it. So with Consul, it's service registry, with Vault, it's security, with Terraform, it's managing resources, so on. And so what we found is sort of in that area, layer 7 is definitely where they're heading, like for sure. But 99% of their workloads today are not sort of gRPC or even HTTP in a lot of cases, but they are usually at least TCP based. And so we standardize on layer 4 to get that foundation in first. That is where the identity happens as well with TLS. And then we'll also support layer 7 in a few months, probably, let's say 3 to 6 months. But that's why we did layer 4 first. We got a lot of sort of flack of how can you possibly service mesh with layer 7? But I thought the opposite. It's like how can you not focus all your time on layer 4 right now?
So does that imply then that you're talking eBPF at layer 4?
Yeah, so actually all the routing right now happens in user space. Again, that's one of those things where that's a totally pluggable system internally in the software. But the reason we started with user space is because we could safely cross-compile that to every platform. So I don't know if this is true, but I know that we've heard from users and customers that Connect is sort of one of the best working service meshes for Windows workloads, for example. I think they've had problems finding service meshes that work on Windows well. And that's just because we sort of get that for free from Go and writing in user space. But the idea is that, eventually we'll detect you're on Linux. We'll detect that you have, the right kernel version and things like that. And we'll try to sort of load that module and use eBPF when possible, things like that. But we want to make that automatic for the user. It's like, we'll take the fast lane if it's available. Otherwise, we'll just drop down to the compatibility layer.
You mentioned you've had some of the best performance on Windows. Obviously, eBPF isn't on Windows, so I'm curious kind of about that particular space and how you dealt with it in a Windows environment. Is that just, again, the benefit of Go, or how did you deal with kind of the layer 4 stuff when you were dealing with Windows as opposed to eBPF on Linux?
And again, just to be totally honest, we don't do eBPF on Linux yet either. It's just sort of a plan too. But we did all user space first.
Right. eBPF is kernel space, of course, right?
Yeah, so Windows is still user space, but the nice thing about eBPF is obviously how performant it is. The funny thing is that when we talk to, again, we're talking to the Global 2000 sort of, for most use cases, the difference between user space and the kernel routing is not big enough that it matters. There's obviously highly specialized cases, either companies like, high frequency trading or specific workloads in a company like mobile ad serving. There's sort of certain workloads that it really matters. But because sort of their deployments are so large, we are just working on the less performance sensitive workloads, which is over 90%. Because what we found is even with user space routing, on Windows, for example, Windows does, I think Linux does this now too. I'm actually not fully sure, but Windows does a lot of optimization for loopback networking. Like it's basically like shared memory buffers or something like that. It doesn't go through the normal TCP stack. It's super, super fast. And so for the user space proxy on Windows, the overhead it actually introduces is really minimal. And then we measured it on Linux. I'm not even sure if Linux has those optimizations, but we measured it on sort of a stock LTS in AWS, sort of Ubuntu machine. And the overhead per connection was, I think it was like microseconds. And, to do a full TLS handshake, make another connection back over loopback, and then copy the packets over. And so when you're looking at that, I think it's hundreds of microseconds, not like single digit microseconds, but like when you're looking at stuff like that, it's just most workloads aren't microsecond sensitive today. And so I think, as long as we're heading there, that's important. But I try to encourage people to not get too hung up on it early on.
So you did mention that you do plan on implementing eBPF. What does that roadmap look like?
Step one was really getting this Envoy support in. So the other hard part about the eBPF is, it's pretty invasive, I would say, to the machine. And so it's harder for us actually without knowing, like, do we have full control over the network stack? Do we have the right permissions? And so we're still figuring out the right user experiences around that. But hopefully it'll just be a setting in Consul that you say, like, yes, I'm on the right machine. I support this. Just like, configure it, take over. And then the agent will do it automatically.
Any integrations that you might use with something like Cilium to be able to handle those?
That might be what we do, yeah. We're not fully sure yet. So we have someone on the Consul team that's he came from like, I want to say like 15 years of networking, like bare metal to the firmware at the firmware level. He came from like the protocol level networking background. So he's also super familiar with the kernel networking stack and things like that. So we have someone who could definitely do this stuff, but we're not 100% sure how we go about implementing it. It's not really even a technical question. It's just like, what's the right partnership question? What's the right user experience, that sort of thing.
You mentioned several times that you all are using Go. What led you to focus on Go for the type of system level networking we're talking about? Why not something like Rust, for example? What made Go the right choice for you all?
Yeah, I mean, it's for us, Hashicorp is a very heavy Go shop. We've been using Go since just prior to version 1.0. We've been using Go for all our products for over 6 years now, I guess it's been. So we try to limit the language fragmentation within the company so that all the skill sets are shared. And so we wrote it in Go. And honestly, we've been very successful writing things in Go, and people make a lot of noise about performance and things like that. And performance is definitely important, but like I said, sort of Consul's used by, a quarter to a third of the Alexa top 50 websites. I think we've shown that we could hit some pretty high performance with Go.
Do you have any numbers that you could share on the performances you're seeing with Consul?
Yeah, our biggest Consul users out there, there's basically two dimensions that I would rate that on: number of data centers and number of single data center cluster size. So for number of data centers, we have a customer out there with dozens of data centers. So I would say over 40 data centers all federated together so they could discover services across any of those 40 data centers. This is a total tangent, but Consul has this really cool feature too, very technical, very fun to look into, called Network Tomography. It's based on some cool research. The implementation is really cool. It's really cheap, but basically for any 2 points globally, so any 2 servers across the globe in different data centers, instantly we could give you a 99th percentile round trip time between them. And so that's pretty neat at that scale. But anyway, that was a tangent.
Actually, it wasn't, because I was going to ask you about the DC story. So I think it actually fits.
Yeah, and that's a very unique feature to Consul. There's really no other software in general. It's service mesh for sure, but even if you look around, it's very rare to find that sort of feature set. And the way we do it is pretty unique too. It's based on this research called Vivaldi by Russ Cox. And what was really cool about it is we've always had this gossip protocol underneath Consul, and that's based on UDP. We were able to introduce this network tomography, implement Vivaldi, and do everything all on the same single UDP packet that we use for the various gossip messages. And so when we launched network tomography, basically we said, upgrade your Consul cluster. There's zero new network overhead. There's a very marginal CPU increase per agent. And now you have 99th percentile round trip time between any 2 nodes in the world. It was really cool.
Very cool.
You don't get those wins very often.
Network tomography. That's a new one on me. I have to look it up. Sounds very, very cool. Okay, so we were talking 40 data centers.
So the largest data centers are sort of over 40. Those users generally have less nodes per data center since they have so many. It's usually less than 1,000. And then our largest single data center user just passed, I think it was 36,000 nodes in a single data center. And so that's 36,000 nodes fully meshed in the same gossip pool. And that was with, I think, 7 servers. So it was 36,000 clients and 7 servers doing the Raft stuff.
Very cool. So let's talk a little bit about deployment patterns that people that are using Consul. So what's the typical deployment? How are we packaging things and typically getting things out?
Yeah, so Consul works best when it has access to sort of the main network. And so the most common case is as an agent directly on the machine. I would say this is common in every scenario except for Kubernetes. So pretty much on-prem, cloud, so on, you're just running Consul directly on the image. So it's either pre-baked on the image or just installed very early on in that life cycle. And then Kubernetes, I guess. So Kubernetes is a little bit different. I think it's a positive thing. Kubernetes has sort of pushed this mindset of like things should not run outside of Kubernetes on a Kubernetes machine. Basically, if it's on the machine, it owns the machine. And so we actually released a bunch of stuff for Kubernetes, a Helm chart and various reference architectures and stuff for running Consul within Kubernetes as well. And that runs as a normal pod.
What about with using something like EKS? Is it friendly for running on kind of a cloud Kubernetes environment?
Yeah, it actually works better right now on the cloud environments because the cloud environments sort of automate the setup of the network layer underneath so that your non-Kubernetes nodes within that cloud, so if you're on AWS, like your EC2 VMs could actually talk to your EKS VMs relatively easily. Whereas due to sort of the network overlays and underlays that happen on-prem, that's not really common. And so it's nicer on cloud right now.
What about observability? So we've talked about a lot of things, but one of the main things that we really get when we're using Service Mesh is a really good kind of observability, tracing kind of story. What's the story around Consul and observability?
Currently, Consul doesn't sort of help you with this in a big way. What we are saying right now is with this Envoy support that we're releasing is, we have a pass-through so you can put any sort of configuration in the Envoy configuration you want. And we're recommending you use Envoy for configuring that tracing. This also goes hand in hand with the fact that Consul as a control plane doesn't yet understand layer 7. That's coming, like I said, in a few months. And so we'll have the official Envoy support in a couple weeks, and then we'll have layer 7 coming out in sort of the next half year to be safe, let's say. And those together, we could then do an automatic, better observability story. Our pragmatic viewpoint, our why to that is similar to layer 7. I think observability is super important. It's something that we're getting to and people want, and there's good reasons for it. They don't want it for no reason. But I think some people with observability are running before they're learning to walk, or walking before they're crawling, or whatever metaphor you want to use. They see these companies with very mature sort of operational expertise, both human and technical, and they have observability, and they want observability for themselves. But the reality is, I think you need to solve sort of the base connectivity service mesh problem before you could really reap the benefits of observability. And so we're trying to get that deployed and in production with these large companies first. But it's important to tell them, and tell the listeners here too, that like we care a lot about observability. We've already thought about it in the design. It's just not fully implemented yet.
So what's up next for Hashicorp? What's on the roadmap?
So that's a hard question just because we have a bunch of different products. The company is big enough now that all these products are happening. Development and road mapping is all happening in parallel. They're all sort of doing their own thing, obviously with the same vision in mind. But the roadmap really right now, the big focus is a lot of Terraform, a lot of Consul, a lot of Vault, I would say. And Consul's big thing is service mesh. Vault, our conference is in a few weeks, and we're gearing up to release a major version of Vault there. So stay tuned about that. We're doing a lot of Kubernetes work across the board. I think that's a big common thing for Hashicorp is we really want to enable Kubernetes. And that's important for us, not just because we definitely do believe in Kubernetes as a platform, but it's important because, again, we believe in heterogeneous environments. And the reality that we've heard is that there's Kubernetes for sure. And even if you're planning on being 99% Kubernetes, that's going to take you years. You still have VMs, you still have on-prem. Like, how do you actually enable security between all that? How do you enable connectivity between all that? All the same infrastructure setup. So that's what we're looking at with our products right now.
I asked this question of all the speakers at QCon, so I'll ask it to you too. What's the tech problem that keeps you up at night?
There's a lot of tech problems I'd love to see solved, but the one that it doesn't keep me up. Luckily I sleep okay. But the one that I worry about the most is we're getting a lot more Vault usage. I'm really happy about that, but it still scares me that security still is mostly up to the user using the security tool correctly. And, you're only as good as how well you use a security tool. So, my biggest fear is that I wake up, there's some news and some big company had a huge data breach, and then it gets leaked to their Vault user, and it's not necessarily the Vault software, but it's how they used it. I'm not trying to blame sort of them, but it's how can we as a vendor make security more automatic and setting a correct security setup and make that easier to consume? That's what I think about, because I think that's going to be the downfall. We like to say internally, when you look at the adoption curve of software, right, you have the early adopters, early majority, that sort of curve. The early adopters are usually the the ones that understand the space the deepest, have like the deepest set of knowledge for some sort of space. And so they're coming into Vault or something already understanding security to a certain extent that the early majority and the laggards like aren't going to understand. Like they're looking to click a button and be like, am I secure now? You can make fun of that all you want if you want. I think it's reasonable in the sense that, they're focused on other things and you should be able to get security that easily. And so that keeps me up in that. Like, I think that's the next frontier for us in a sense, because if you look at Vault today, it supports a ton of features and it hits a ton of compliances. It's used by some governments. Like it hits all these like hardcore, quote unquote, like checkboxes. And that's great. But now I'm worried about the casual user.
It makes sense. It's undifferentiated heavy lifting for folks. That's not their core business area, right?
Right. I never wanted to know this much about security, to be honest.
Yeah, I get it. There's one more question that I want to ask, and I don't think it's actually a short one, but I'm curious on your response. So a lot of the time at the service mesh level, we're just talking about routing, we're talking about TLS, but I haven't heard a lot of discussion about how machine learning and AI is going to be used in creating sort of this substrate for services. Put on your crystal ball for a second. I'm not, holding you to anything. How do you see AI and ML kind of affecting the space of like service meshes and this networking between services?
Yeah, timely question, because we're about to talk about some AI ML stuff at our conference, and not to ride on the bandwagon. We have a research team at Hashicorp. And when I say a research team, I mean we have at any given point 2 or 3 currently full academic PhDs focusing on some cutting edge area of research with the intention to publish papers. Like we have a research arm. The research team for us at Hashicorp for the past couple of years has been focused on a problem that we're about to talk about publicly. We're basically trying to, recommend better ways to run software securely. So with Consul, this is not what we're announcing. Consul's a little bit down the road, but like without giving it away, here's sort of like a use case dream of what we're pretty sure at this point we could solve. We have proof of concepts and like we'll do it. But what we want to be able to do is, start with the most open sort of security policy, because what we found is in practice, people tend to err on the side of overly permissive security policies, because if they're too restrictive, they're broken. If they're too permissive, they're not broken until you're breached, which is kicking the can down the road. And you know how much people love to do that. So usually have these overly permissive. So what we want to say is, start with the most permissive, just allow all or allow some like broad scope for your team. Let that user use the software for a while. And then, we'll give you the optimal policy based on their use case. And then we'll err properly when they're also behaving out of bounds. And so we're working on software like this. And because we're doing it in our research team, we did the research in a generic way, sort of the algorithms we've been investigating and how to store data and things like that. But we're hoping to be able to apply it to multiple pieces of our software so that you could get that behavior. Because this goes back to what keeps me up at night. Is like Vault policies. I've been into some customer sites and I've seen some Vault policies, and they're definitely not optimal. And I would love for that to be easier for people. My dream is they open a UI, a security operator opens a UI. They have a ton to think of that isn't Vault, but they open the Vault UI and Vault says, good morning, like here are 4 security policies you should review because we don't think they're optimal for these reasons. And I think an important thing we're doing is we're not doing automated remediation. I think that's scary. What we want to use AI and ML for initially is just recommendation. It's just, we won't do anything on a human's behalf. The human is fully in charge of what actually happens. But we will provide smarter reporting and smarter visibility so that you can make more informed decisions.
I love that. It's a great approach. All right. So Mitchell, thank you for joining us on the InfoQ podcast.
Thank you very much.